Recording. Okay. So, you may have noticed me testing something. I think that I made an error, which shouldn't be too big of a problem to solve. Here is this week's program. And, I mean, this week's, what do you call it? Assignment. Did I use the word raw anywhere? Okay. No, I didn't. Good. Because at Python 2 and Python 3, this particular function that I'm about to talk about changed. So we're going to do we're going to do some of the labs we're going to start each of the lab programs. Okay. And I'll save them all out as Jupyter notebooks, so you can have them, and I'll put them up on GitHub, so you can actually download them and use them if you want to.
So you're talking about like do the following assignments 1, 2, and 3 being each one.
Yep. So in order to do that, one of the concepts that the book talks about that I want you to do is implement a user basically having to input some values. So we'll just start out with the first one. I'm going to say file, new notebook, file, new Python 3 notebook. And I'm going to go ahead and name these the way I want you to name them. So you name them your name, underscore your first name, underscore the exercise number, which in this case is 2, underscore the item number, which is 1. So this is too small to read. This should be Raver underscore, so last name underscore first name underscore exercise number underscore item number. And for this week, if you look, there are 3 functions. I have them numbered: 1, 2, and 3. So you're going to turn in 3. You're going to turn in 3 functions. Okay. Not 3 functions, 3 programs.
3 notebooks, like 3 notebooks.
3 notebooks. You can technically, I mean, I'd rather you use the Jupyter Notebooks concept. That's new for this semester. You can do it as just a .py file. That's the way I had you turn them in before, .py. But yeah, I'd rather you did it as a Jupyter Notebook. And I thought I'd updated this just before class, so I guess I'd messed up. But turn these in on Canvas rather than turning them into the email, and I'll update that too before the class is over. The page number is correct, though. I updated that before class. Yeah, I did an update, but I didn't change hardly anything, but that was one of the things I changed, and that's correct. And then update it to Canvas. So we're gonna walk through each of these. And so I renamed this. I'm gonna rename it. Okay. So now I know this is the exercise. I'm actually also going to write 2019 in case I ever teach this class again. Things change. The previous year it'll be obvious as to which one was for this year.
You want us to put the other?
No, you don't need to do that. Okay. Because hopefully you don't have to take the class again next year or the year after.
Yes.
It'll be this class is on a 1.5-year rotation, so it won't be taught again. Because it's fall, right?
Mm-hmm.
So I should have dot Elvis 1.
So it'll be taught again.
2 dot Elvis 3.
It's underscore, but yeah. Yeah, Elvis underscore dot underscore 2 underscore 1. So everybody is 2 and 1. Okay. All right. So let's read the requirement for this this one. So this one is modified from the book. The other 2 are not. So basically, if you're given 3 sticks, we're going to write a function to decide whether or not they're a triangle. That's the quick version of what that says. So the 3 sticks are just going to be lengths. You're going to get 3 lengths from the user, and then you're going to need to return, are they a triangle? Will they make a triangle is probably a better way to say that. And so what I want you to do is you have to do it this way. You have to write a function called isTriangle, and you have to call that function in order to get an A on that particular one. So you have to write a function called isTriangle, and it takes 3 arguments, and it prints out yes or no, depending on if they are. And then you'll read the full requirement here. So your program prompts the user to enter 3 stick lengths, converts them to integers, uses isTriangle, which is the function you wrote before, with 3 given lengths, and the user must be told if the sticks form a triangle in a complete sentence. So it's not just yes or no, right? So the function is going to return yes or no, but then you need to modify it a bit in your returns, in your actual program. So let's walk through that. So the first step here is to just write that function, right? Now, I'm not going to actually write the whole function for you, but I'm going to show you the beginnings of that. So let's do that. So right here, let's say, how do we define a function? EF. And then we already said what the function needs to be called, right? It is triangle with an underscore. IS triangle. And then what does this part need to look like if it's gonna have 3 parameters?
Like an X, comma, Y,
ABC?
comma, Z.
Yeah, X comma Y, or I don't actually say what they're called, but yeah, we could call it XYZ or ABC, or we could call it 1, 2, and 3. Any of those are fine. And it doesn't matter if you call them something else, but it needs to take 3 parameters, and then we need to have a colon. And then you're going to, I'm going to put some comments in here. So this function should return yes or no if the 3 inputs can make a triangle. So what are the 3 tests that we need to run?
Okay.
So basically, no side can be longer than the other 2 sides. So one of the concepts that I kind of skipped over here, the book covers this a bit, if I go back up here, is called composition. Now, it might be possible to write 1 line of code that tests if that's possible. In fact, I think it is possible to write 1 line of code to test whether or not that single statement is true. So any 1 line can't be longer than the other 2 put together. That's what we want to do. If you can think about that, then you can write that out. So I'm going to write that right here. Test if any 1 line is longer than the other 2 added together. Personally, I would rather do it like this. Test. How many tests total do there need to be, really?
3 tests? Let's see.
Yeah, 3 tests. What can you say them?
Is 1 greater than 2 plus 3?
2 plus 3. Yes, that's one of the tests.
Is 2 greater than 1 plus 3?
Yeah.
And then plus 3 greater than 1 plus 2.
Right, right. And if any one of those are true, the whole thing is wrong, right?
It's false.
Is false. It can't be a triangle. Right?
Right.
Yeah. Okay, so you need to put some code in there. So I personally would like do something like this. If 1 is greater than 2 plus 3. See, that's just doing one of the tests, right? So I could call these things like test 1, test 2, and test 3. Test 1 is equal to true. By the way, if you use true and false instead of 1 and 0, the words true and false need to be capitalized. I think I demonstrated that, but I didn't say it yet. So test 1 is true. You could do 3 tests, right? So that's just the way I might do it. You're welcome to do it a different way. So to do this, I would have to say, that's not what I have to say. Okay. And then at the end, I'd have to, here, I'd have to say, ooh, something happened over here. I might be a little, is that a comment about me talking too loud, maybe? You might be a little too close to your mic. Oh, don't talk so loud. Okay, so here I have to write a test all 3. Okay. All right, test all 3. So something like this. If test 1 and test. Right now I'm just going to write.
We don't have test 2 yet. Steve.
Yeah. Test all 3. So right now I'm just going to say if test 1, return yes, and else return. All right. So So I'm going to write that comment in there. So what I'm trying to say is, now this will run right now. But right now it's only testing 1 of the 3 legs. See what I'm saying? It's only testing 1 of the 3 legs. So it's not a complete answer. But it'll actually run. Like, it won't return anything right now because we actually have to get into returning it. But one of the nice things about writing functions is that you can actually write a function and just kind of stub it out and get it to return a possible answer, and then write your function later, and you can go on with writing the rest of your program. So we have that function written, but it's not completely right, but it's right enough that it's always going to be returning the answer, the yes or the no answer.
So you troubleshoot the code, and then once you finish doing all the statements, you just write one statement.
Well, we'll go back and finish that later. You'll go back and finish it later.
So like to add like for test 2, would you add that on a different indentation or would you add it just underneath?
Personally, I would just say if test 1 and test 2 and test 3. In other words, they all have to be true for it to be true. And so that's the way I would do it, if you're asking me.
Okay.
So I would do each of the 3 tests. Now you're going to have to actually expand this a little bit because you're going to have to do something like if this is true, and you might want to do something like this, because you're going to need to do that. Otherwise, the reason why I need to do that is because you need to create test 2 before you're going to test whether or not it. Not test 2. Test 1. Save. Okay. So you could do this 3 times. Alternatively, if you want to get really fancy, think about something else you could do is create another function that just did this part, and you feed it like, anyway, you feed it like you feed it in 3 different orders.
It's like a 4 next loop.
Yeah, you could do it as a loop, is what I'm trying to say.
You loop it till you get to 3, and then boom.
Yeah, but
it would say true, 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 or true.
My point is that there's several different ways to write this. And one way would just be to copy this code 3 times and call it test 1, test 2, and test 3, and just change the order of these 3 things.
But on the same indentation, like not underneath the first if.
Right,
like
right. No, these are 3 separate things. Test 1, test 2, and test 3. All right, so that's that. Right now, it's just all it's doing is returning the result of this one. So now keep in mind that you're always going to have to rerun this box every time you make changes to this box. So later, when I write the rest of the code, if I go make changes to this, I'll need to rerun it before I rerun the other code. So what I'm going to do is separate out this function from the rest of the code. Okay. So now I'm going to talk about that other thing that I want to talk about, and that's the input statement. So what the input statement does, or sorry, function, it's a function, is I'm going to call this like side 1 is equal to, and then I'm going to use the function input, and then what goes inside of this function is the prompt. So I could say something like input the first side of the triangle. I always like to put a space here. You'll see why in a second. So now I'm going to run this. Watch what it does. It actually prompts the user for a value. So I could put like 5. And then if I hit enter, it, yeah, nothing's there. But now what happens is the variable side 1 acquired this function. Inside of this function is what you've returned here, 5. Okay. I want to modify this just a little bit and actually write type, because this is important. What do you think the type of that return value is going to be?
Well, you got to assign the value. You want to assign the value of your input to one of the sides to get all of them.
It's a string, I would imagine, until you make it a new one.
Yes, it's a string. So it's allowing the user to put whatever they want. They can put, my dog ate my homework. Like, there's no check on what they put. And so it's always going to be a string unless you decide to change it. So that'll be important, because what if you never changed it and this was 5 and 6 and this was 1 and this was the value, like, let's say side 1 was 2, 3, and 4. What would happen?
With their strings, it wouldn't add.
3 and 4 would add together to be what?
3 and 4.
Yeah, a 3 next to a 4. Okay? And I don't know if 3 and 4 is greater than 2 in terms of numbers, right? I mean, sorry, in terms of strings. They actually do have the concept. So a greater than, less than in strings is how they sort alphabetically. So,
So 3 would be before 2.
yeah, I guess that's true. But it wouldn't be correct all the time. And so you actually have to convert these. That's why I said in the assignment, I said that you have to convert them to integers. Okay? All right. So in best practices, it'd actually be good to return to the user if they weren't really a number, but we haven't really discussed that yet. So we're just going to assume that they entered it right. Okay, so we'll change this to, and let's say side 1 equals int side 1. So what does it do? What is that statement doing right there? Side 1 equals int side 1.
int, now you're making an integer.
Right. And I'm reusing that variable, right? I'm taking the value 6 out of the container. I'm converting it into the number 6, and I'm putting it back into the same container. I'm overwriting that value. And it's not a problem because I don't need the string number. I mean, I don't need the string representation anymore. So I could just, copy and paste that 3 times and change the number here. All right, does anybody have any issues with what I wrote there? Or questions? Now watch when I run this. I'm gonna be prompted to enter the first side of the triangle. So I can enter 5. I press enter. Now I'm gonna be prompted to enter the second side of the triangle, 7, and then 9. Okay. So I entered all 3 sides of the triangle, but still nothing happened except for they were converted to integers. Yeah. Okay.
It's already copy pasted. It's out to 3.
Is anybody's asking for the input?
When I did the 1 it did, but I haven't tried the 3 yet.
Okay.
It did like ask me.
It is. For some reason, it's like stuck running. That star means it's still running. Why it's still running?
Mine let me do it.
I just refresh the page. I just turned no, I was I didn't think that was the problem. Would you? So I actually just restarted Jupyter altogether. I don't know why that's all the problem, but that's what I did.
So if you're doing this for the summer, you take it 12 and 13.
12, 13, 13. So yeah, that popped up because I stopped Jupyter. I'm gonna restart Jupyter. Oh wait, maybe I did. Did I stop Jupyter on your computer? Or?
You did on mine, yeah.
Yeah, I did on yours. Well, this was that one.
Oh.
My finger must be. That worked for him. Oh, so is that always there? Okay, so I think I did. Research notebook already.
Very good.
I don't know why. I mean, I'm not sure, but it did work to just restart
Okay.
Jupyter. What about you? You got it?
Fine.
Okay. Yeah, 12, 13, 13 should work, right? Because 12, 13, and 13, or 12, 12, 13, those would all be valid triangles. It's almost an isosceles triangle. Almost.
So how are we making the second section, the side one input and the integers? Are those going to be plugged back into our 1, 2, and 3?
Yes.
So we should ideally name them. If I'm doing A, B, and C, I should name them A, B, and C instead of side 1, side 2, and side 3.
No, you don't have to.
Oh, okay.
So here I'm just going to call these answer is. See what I'm doing here? Side 1, comma, side 2, comma, side 3. So Ashley asked a good question. She said, should I name side 1 and side 2 and side 3 the same thing as 1, 2, and 3? And the answer is, if it helps you to do that, that's fine. Sometimes it actually, in my experience, it makes it harder for me to understand because these are separate things. Side 1, side 2, and side 3 are global variables. 1, 2, and 3 are local variables that only exist inside the function. So we're passing in this value, and yes, it does become 1 in here. But I want to make sure that I'd never use 1 out here because it doesn't. The variable 1 doesn't exist out here. Okay, I'm giving it a new name. In other words, I'm passing the value in, and it's in a different container at that point.
Oh, okay.
And it's called it's a container called 1 just for a little while, and then it actually disappears inside once the answer is calculated.
Okay, so you pretty much, that's just the placeholder for you to put in your side 1, side 2, or side 3.
You can name it the same thing. You can call this side 1, side 2, and side 3. But you have to remember that this side 1 and this side 2 and this side 3 disappear after that's done. This side 1 and this side 2, this side 3 exist all the time. So even if let's say we went in here and we had a function and we called this side 1, and inside the function we said side 1 is equal to 5.
Right.
That wouldn't change this side 1 value. It would only change it inside the function.
So
Next week we'll learn that there are cases where that doesn't always exist. In some computer programming languages, when you pass something, it's always passed by value. Sometimes it's passed as a reference to that thing. In this case, in Python, numbers and what we call kind of standard data types are always passed by value. And objects, like sequences, are passed by reference. And so when you pass it by reference, you can change them inside of a function. But we'll cover that more next week. What's your question?
So the bottom side statements, they're not connected yet to the top function because they only put those values inside of a container. We had linked the container to that triangle down there to that containers up there. If we did, then we could run that program from this input to the bottom, right? Those are not two connecting programs right now. They're separate programs until you link those into those.
Well, until I call this function.
Right.
I'm calling this function, and then now it's going to run this code and return the answer.
I don't think mine returned the answer.
Okay, so triangle is the actual function, and you defining the items in a container box. But once you said triangle, whatever what you did before, right? To the problem.
It's gonna put these numbers, whatever these numbers, these are just words that represent a number.
Right.
And so it's gonna put those numbers in there, run this function,
Right.
and return a yes or a no. So I'm gonna print answer. Okay. So now I'm gonna run this guy, and I'm gonna go 4, 5, 6. That should be a valid triangle, but it says no. Okay. Why does it say no?
I think you only have the one side, right?
2.
Okay.
Oh yeah, it's actually not a valid triangle, right? Because 1 is 4. Is 4 greater than 2 plus 3? No. Wait a second here. So I got to figure out what's wrong. Because, right, let's look at the logic here. So 4 is greater than 2 plus 3.
Well, it's 5 plus 6, right?
Or 5 plus 6. What's 5 plus 6? 11. No, that's not right. So that should be false. Actually, yes, so my logic is fine. This is actually should be yes or no. So in other words, well, I'm just writing this, or I could change this. In other words, I just had one of the things flipped. My logic was off. Let's see what mine says. So remember, you have to rerun this.
Oh, I forgot to rerun that.
And then we run this guy. And we'll get 4, 5, 6. Yes, so that should be right.
And you just want something that says yes, and then we'll make a statement after the fact in a complete sentence? Or?
Yeah, so you could just modify. Here, we'll write this. Modify this statement to be a complete sentence. Like that. Okay, modify. Yeah, and then I think you'd be ready.
So you would change. You would say print answer and then have on the outside of it like the actual string and say like, yes, this is a triangle.
Yeah, you could do that. So Ashley suggested that we just write, whoa, totally messed up. That would be a complete sentence. I could put a period behind that. In fact, I might even want to put a comma to make this lowercase for correct English. Oops. I messed up that. I put it. Yeah, I messed up that. Okay.
Are there different numbers? Does the book give us different numbers? Like what kind of test?
No, but you should test both things that you know. You should test things that you know are and aren't. You know what I'm saying? So let's run this so that I know something that wouldn't work. So if I had 1 and 2 and 3, that should still work. Okay, yeah, that should work. Okay, let's do one that shouldn't. So basically, it shouldn't work if it's really big. So 10, 2, and 3. Yeah, no, that is actually. So I need to change. I need to write an if statement in here somewhere. So actually, that wouldn't work.
So you should say no. This is not a triangle.
Yes. Yeah. So you'll need to have an if statement in there, but yeah. I jumped the gun when I said that would work. So modify that statement to become a complete sentence. All right. So really the two things that you need to do here are marked out in code. You need to test to make sure that they actually work, and then you need to modify the statement to be a complete sentence. And if you do that, you'll get full credit on that. Okay. All right. So that would be how to do that. Anybody have any questions?
So,
Michael, yeah.
did you finish it for, like, when you said no, if it's no, there's a different sentence? Or do we have to do that on
Yeah, you have to do that on your own. So Ashley just suggested that, and off the top of my head, I thought, oh yeah, that'll work. To just write yes, comma, this is a complete sentence. But then if the answer is no, it still says no, this is a complete sentence.
Right.
Mine's not. I ran something I knew wouldn't work, and it's still saying yes. I must have something wrong.
What did you run?
10, 1, and 2.
10, 1, and 2. Yeah. So yeah, you must.
Well, I copied and pasted the 3 different sides and rearranged them on the top. Yeah, and that one.
Yeah. So yeah, somewhere in your logic, we can. It's just your logic, so we can look at that after class when I help individuals. Because yeah, I could write up an answer right now, but that would kind of defeat the purpose. So everybody should get an answer or work with somebody else to get an answer. But yeah, what I would look at actually is that make sure that your test actually is correct based on what's here.
Okay.
Yeah. So getting back to what I said before is you could actually write a big statement like if this and this and this, or you could put it all together and not have 3 tests. That's fine.
So it seems to be like the simplest would be if this equals this, or if this is greater than this, or this is greater than this, or if that's greater than that, print this is not a triangle. Else, print this is a triangle.
Right. Now, that would be very simple. However, the requirement was that this the function doesn't return the full sentence. But you're right up to that point. But just make sure that that it fits this. So the user must be told if the two sticks. Okay, now I guess that's fine. Cannot form a triangle. I didn't specify that. So the user must be told if the sticks form a triangle in a complete sentence. You're right. That would work for this particular function.
Okay.
Do you
I
want
did.
it just to be lengthier, just based off of?
No, you could do it that way that you were describing. You could put the print statement in the function. You don't have to have a return statement if you don't want to. Okay. You're gonna need to write plenty of return statements later. So, but you do need to tell them in a complete sentence if it is. It's easier to print 3 stick lengths. Convert them energies. Uses this triangle to check whether the sticks can form a triangle. The user must return to yeah. That's fine. All right. Any other questions about this one? So I saved that now. Okay, so what I told you before, so I've got this point distance one that I copied into that directory and then opened. And I'm going to rename this one, Raber _ George _ 2 _ 2. And then I'm going to put 2019, and you're not required to do that.
Do they have to be in separate notebooks, or can you put all of them?
I prefer them in separate notebooks, each of the problems. And then I'm going to change this because this is the requirement for this function. Okay? The function for calculating distance, 2 points, given in the book on page 53. We already did it, but you could copy and paste it from page 53. Using this function, write a program that calculates the length of a polyline. And we're going to define a polyline as a number of connected line segments. So it's going to use a while loop to continually prompt the user to enter a new vertex along the line. So this is going to require a little bit of help. We're gonna start this out. Each time the user should be asked if the polyline is complete, and then if it's complete, we want you to report the length of the line. So in other words, that's a long statement. What's going to happen? What I want to see is you're going to enter a point, and then the user is going to say, "Are you done?" And if you're done, then it's going to report the length of the polyline. No lines created yet, so the length will be 0. If you say, "No, I'm not done," you'll be prompted to say, here's another point, and so on. So you're going to keep creating points and keep asking if you're done. And once you're done, I want the full length of the polyline, right? So here, so let's just say, we got Cartesian coordinates. That's really hard to see. All right, we got X and Y. So the user gives you a point, like right there, and then gives you another point. And each time through, you need to use the function to calculate the distance between those 2 points. And if they give you a third point, you calculate the distance from those 2 points. And a fourth point, you calculate the distance between those 2 points. And then we need to add all these up. I think it's easier to do it the way we demonstrated when Jordan asked his question, to kind of keep a running total so that we always can say, oh, here's the answer when it's ready, rather than storing every time through, storing another length, then doing the calculation at the end, which we could do. So let's kind of write out what the basic form of this is going to be. All right. We kind of wrote this as a bunch of, so I'm going to delete this cell. There's a bunch of cells we can delete in here. Delete that cell. We don't, oh, we do need that cell, no. I think this is the right answer. So everything beneath that.
Well, don't you need to add together and square them?
Oh,
That's
yeah.
what that was, I think.
Yeah, so we'll keep this cell, but we don't need this cell, the Python. We don't need this. Sorry, what? Okay.
I have a step 1, a step 2, and a step 3.
Yeah, so this is also step 3. Okay. We don't need this one. Well, that one will be fine. Okay, so really what we want to do is we want to modify this so that it's a function. So I'm going to put all of them in the same cell. So I'm going to take step 2 and put it up here as part of the cell, and then take step 3 and put it up here as part of the cell. So now we've just got one cell instead of having a bunch of cells.
Do we need to print the difference just so you can see if they're working? We don't need that necessarily. That's step right. Underneath step 1.
Where's that? Step 1. Oh, yeah.
One.
We don't need these print statements anymore. You're right. Just we don't need this print statement. We can get rid of it. In other words,
Is that from last class?
it is from last class, and so it's if you go to, you could download it. If you go to last week's class as M1, I have it right here, called pointdistance.ipynb. The other alternative that you could do here, I'll just show this in a separate cell. This is what I was saying. You could go to the book. If you go to page 53, it's hard because the page numbers don't actually match the page number. I'm talking about the page number that's printed in the text. the PDF actually counts like even the, you know, the front matter and stuff. Okay. Now there are some concepts we didn't really discuss. So when you go through here, we didn't talk about recursion, so you could just skip over that. I mean, if you're interested in learning about it, it's kind of cool, but we didn't talk about it in this class. All right. We did talk about conditionals though. Okay, 53. So there's the distance function that he wrote. Okay. But that's not actually right. This is actually the right distance function. This is just an intermediate step. This is actually, sorry, not that one. This is actually the real one. Okay. So he did the same things we did. You know, the difference in the x's, the difference in the y's. He said dx instead of, I just had different values. But one way to start this off would be to just copy this function right here. Control C, put that into a cell, Control V, and you'd be good to go. But it didn't copy the indentation, so you'd have to. Okay. So what I was going to do next was turn this into a function. But this also works. How do we turn this into a function if I wanted to turn it into a function?
You have to.
What's the key word to create a function?
Yeah.
Def. And we're going to call this distance as well. And I'm just going to change these.
Can you scroll down to the bottom one real fast just so I can see?
Yep.
Oh, it's all of them.
It's all of them. Yeah. And then delete this. Okay. So these two functions right here and right here are the same. They're just, well, this one's, the top one's commented up a little bit more. But you see that the same thing happened, right? I just called him y diff, x diff, he called him dx, dy. And step 2 is the same, except for he did it as like 2 steps. And he did, so I did just the squared part, and then he added them together right there in the same step. Okay, but I did this last step in there. We could do it a third way and just write all that as one whole line, but anyway, it's either of those statements are the same. The problem with this one is that he's going to need to either import math, or we can just write it the way I did. Instead of, we could just do. I'm gonna modify this, or it wouldn't run. You need to either import math, or write it like that. But it's the same thing. But both of these functions are now the same, except for I'm not returning my result. So I'll put return. Whoops. Return right here. So I'm going to run that. Do I get any errors? Oh, all this needs to be indented. All of it. No way to indent quickly. All right, so I'll just go in here and tab all these over. In some editors, like Notepad++, you could indent and dedent a bunch of lines if you highlight them. But anyway, both of these run. As soon as you run this one, it actually overwrites this one. So a function is just a variable in the end. So this function, I ran it, and then I ran this, and since they're named the same thing, this one overwrote that one, but they're the same. So I just want you to know they're the same, and I just created that. In fact, I'll put a cell up here. I'll modify this. These two functions return the distance given 2 points. In fact, I'll rephrase this one. I'll call this distance book, so that we can test to make sure that they actually run. We can do that right here. Print distance 2, 3, 5, 4, 5. Print distance book 3, 4, 5. Oh, they're in different orders there. So let's actually keep the orders consistent. Y1, X2, Y2. Okay. See how the order. So now the orders are consistent between these two functions. In computer science terminology, what we did was we made the signatures the same. So a signature has to do with the order that parameters are arranged in the function and what those parameters mean. So here, the XY pairs are next to each other in both. The order does matter. So if you put X1, X2, Y1, Y2 the way I had it, then it would interpret these two differently. Like the numbers go in this order. So 2 becomes X1, 3 becomes Y1. All right, so I'm going to run this to make sure that I get the same answer. Distance book. Did I even run that one?
But you didn't find any values for distance book, did you?
No, it's fine. I just didn't run it. I did get a different answer. So let's see. Added them together. I squared them. Added them together. 0.5. You got the same answer?
Yeah.
Is that because they don't have the math book in there?
Did yours still say math or no?
I changed it to times 0.05.
2, 3, 4, 5. 2, 3,
Wait,
4,
no, it
5.
did have import math on the top one. I kept the top one.
But does it say math down here? Or did you change this?
On the second one, yeah, I changed that one to 0.05. And I got 2. The bottom one's right as far as I have it, the 2.82.
Do you have both of them as 2.82?
Uh-huh.
Let me see what I did differently. Squared the two differences. That should be right. And then I added them together. That's the same as that. Oh, you know what I did? It's going to work now. I know what I did. No, that wasn't actually the problem. So the problem was that I ran this. I mean, I flipped those around, but I forgot to run it before I did it. So that was the problem. It's interactive Python. Gotcha. If you don't rerun the cell where you make a change, and you can, as I've mentioned before, that didn't create it like. Let's see. Anyway, run. So now those are the same. I was just showing you those same. So I'm actually going to delete this. Oh, here I'll leave it in there. Just to show that they're same. Okay, so now what I want to do is, it doesn't really matter which one it is, but you need to use this function, and you need to create a while statement that is going to go through and ask the user for more and more points. And each time through, you want to calculate the distance to the last point. Okay? So it's a little bit of a logical problem, right? So let's think about what needs to happen. So we need, each time through is going to require what type of thing that we talked about today. In other words, looping, right? While. So we need a while statement, and we need to think about how we're going to create this while statement so that it always will ask if there's another point. What we could do is something like this. Input. And sometimes it's helpful to specify exactly what you want them to put. Okay. See what I'm saying? Something like that. All right.
We just copy the top line and put it.
Yeah. So what's this going to do right here? What's that first line do?
It's gonna prompt them to type in yes or no, huh?
Yeah. Right. Do you see what I just did? I put a quote around the Y. Why did I do that?
Because it's a,
Who knows it's a text or a string?
Yeah. Otherwise, yeah, it would be looking for a variable named Y, and it would actually. Like here, I'll show you. So if I left the quotes out and I ran that one, it's gonna when I enter something here, it's gonna give me an error. It says Y is not defined. So I need to say that. So now when I run it and I say Y, it'll say give me another point. Y, give me another point. Y.
You're talking about
Yeah. Okay. Exactly. So the first thing asks for a yes or no. How do I get out of this loop?
type it in.
Yeah, technically, what happens if I type no?
no, you need,
We'll just
Yeah.
switch.
Do I need an N though?
yes, you need it. You should stop on it.
Yeah. Well, this is just the prompt that I have created.
Okay.
But I need to look at the logical flow of the program. The logical flow of the program just says while user input equals Y.
So anything.
So anything that's not Y causes it to stop.
Well, then you got to point it to if it's no, then you stop.
Well,
You see it?
I could, but I have to rephrase this in a different way. I would have to say while user input does not equal N to get it to do the N. But then the opposite would be true. Anything besides a Y would cause it to continue. See what I'm saying?
Right. But
Yep.
you want to choose either yes or no.
Right, but those aren't the choices. I'd have to enter a lot more things. So even if I enter yes and I press enter, it stops executing. You see that?
Yeah.
Why when I put S, yes, why does it stop executing?
Well, we put it as for the Y, not for yes.
Right. So if I wanted to, I could put an OR statement here and say user input equals yes. Okay.
When you say like user input yes, does it have to be with caps?
It does. It's case sensitive.
Just put one user input and just put Y or yes. You have to put a whole other user input.
Right, but one programming trick that people often use, where I put my function, is that they convert everything. Whoops. They convert everything to uppercase to do testing, or everything to lowercase, and then it doesn't matter.
Is that what the upper's doing?
Yes. So now, when I run this, if I enter yes and lowercase, upper is not defined. It's probably part of a different package. I got to find out what package upper is in. Python upper function. The built-in module. What? It says string.upper. Let's see if I just type in string.upper for string. You're right. I could just write if it's yes, if it's capital yes, if it's capital O.
If it's yes, all this here, then keep going on, and else is gonna go right into no.
Yeah. Yeah, you're right. I mean, it's just a matter of preference. Nah. Anyway, I was just trying to teach that. S.upper. Oh. So it's actually a function of a string. So anyway, here is the correct way to put this. There we go. And these are functions, so I do need to have that. I'm pretty sure. Let's see if this works. Yep. Okay.
That's what you're saying. It's not case sensitive.
It has the effect of making it not case sensitive. So it was just Elvis's question was, well, you could, or not question, his statement is, you could just say, while user input equals big Y, or while user input equals little y, or while user input equals yes, or while it equals yes lowercase, or yes with a capital Y. I mean, you'd see how if there's a bunch of different choices that you want to give the user, you need to think a little bit, and you might be able to write it in a shorter way. And so I took advantage of this ability to convert the case to always upper. So it doesn't matter what the user inputted, it's going to convert it to uppercase before it checks. And so what I'm doing basically is saying, I don't care about the case. If it's equal to Y, or if it's equal to yes, continue. If not, then stop. Okay.
And you have to put your yes in all caps, or else.
Right. Or I could use lower and put it in lowercase. But that's exactly right. You have to check the right one. So now we have the framework for doing this statement. Now we also have to ask the user, though, for the point, the X and the Y point. See what I'm saying? Okay, so we'll actually do that part together here real quick. So, whoops, maybe one of the things that I need to do, yeah, there we go. Okay, so I could do x1 equals input, and then say something like give the x coordinate of a point and y1 is equal to input give the y coordinate of a point. Good. All right. Okay, so now I have x1 and y1 defined, but I need to do that again to get the second point. Control C. I'm going to put this inside the loop. Instead of saying give me another point, I'm just going to get it. So I'm going to change this. Yep. Exactly, right here. See that? But I'm going to change these from 2 and 2. I just deleted the part that said give me another point.
You're saying x2 because these lines are all building off of one another.
Yeah.
So they're not like a line here and then a line here. They're like making a shape, like connect the dots kind of.
Yep.
Okay, so that's why we're doing only x2.
You gotta change in that statement to give me the x2 point.
No, because the next time through it would be if we kept going the loop, it would be
Okay, it's
The
still
twos
good.
would then
well,
flip
let's say
around, right?
of the next point, because it'll always be the next point, right? That way it'll be a little less confusing. See what I'm saying? Maybe that's better. Elvis, you think that might be better?
Yes, sir. I guess. So it does already define that you're the x2 point asking for that question, or you just already assume that you're asking for the second x point. Is it assume that you're asking for the second x point?
Well, we need to have both of them in memory. So.
But are you telling the person that input the point is this x2 point? Because they might say, am I doing x1, x2 point? Not that it's important, but I'm just saying you define it along the way.
Right.
You redefine it. It's just probably too much.
Well, you might be able to do what you're doing, but it's a little fancy to like keep asking the point. So I can maybe show how you could do that in a second, but.
So pretty much the way we have it now, you have point 1 and then point 2, and you run it, and then when you start the next one, point 2 becomes point 1, and you do pretty much point 3.
Exactly.
Okay.
So Ashley made a great point. So the next time through, point 2 becomes point 1. So we need to put that in the program somewhere, because that's exactly what needs to happen. So we need to do that. We just do that by doing it. x1 is equal to x2, and y2 or y1 is equal, or y1 is equal to y2. But before we get to that point, we need to calculate the distance.
They don't have the program.
Well, we have to actually do it. All right? So you have the exact, so right now we need to calculate the distance between x2 and x1. And we need to store that distance. Then we need to reassign the variables so that next time x1 is going to be the old x2. And the next time through the loop, it'll keep, x1 will keep moving, x2 will keep moving back to x1 and we'll get a new one. And then we'll get a new one. And then we'll get a new one. And we'll keep calculating those distances.
So to calculate the distance, we would just say like print and then put our function that we made.
Right.
Okay.
So the distance is going to be exactly what she said. So we could do print and then distance, and then we just feed it x1. Now these just happen to be named the same thing. But remember, they're not actually the same variables. I mean, we're feeding them in so that they're the same, but these are the global variables x1 and y1, x2 and y2. We're feeding it into the function, and we're passing them by value. So even if we modify them in here, which we don't, but if we did, they wouldn't change these values.
So, so you just named the global value x1 equal x2. Come back down to one.
Yeah, sorry.
Okay, x1, x2. So, that a print statement don't do anything but the fact. Okay, I was just looking at it. So the x1 becomes x2 when the problem is run.
Yeah. All right, so let's test this now. All right, so we're going to run it. And the first thing it's going to do is give the x-coordinate of a point. Give the x-coordinate of a point. So let's make this simple and start with 0, 0, right? So where's 0, 0 in Cartesian? What's another word for 0, 0 in Cartesian coordinates? The origin. Okay, exactly. So the x and the y is 0, 0. So if I go out to 3, 4, that forms a triangle that we all know the right answer. Well, like there's some perfect right triangles. So 3, 4, the hypotenuse is 5. Okay, so I already know that. So it'd be a good one to check. So if I put in 3, oh, sorry, you want to add another point. And because it's not yes, it quit out. So
Mine's not prompting me to put in.
I'm going to run this again. 0, 0, and then I have to put in yes. And now give the x-coordinate. If I go 3, 4, it didn't actually print a distance, did it?
Mine's not even letting me put in the point for some reason. I think I have to put the princess.
What about putting a value in? Just put 1 on the coordinate.
Let's just make sure it's running this function. Just gonna make sure it's getting in there. So I'm gonna run that function again. There's something wrong. Look at how it's just like running forever. Stop. Yeah. I don't know why it's doing this. I am going to, so this happened back there a couple times. So I closed Jupyter down. So I think that the input function, which we're not going to continue to use throughout the course, we're going to have other ways to actually input stuff.
Does it save? Like even if it's not.
It seems like it keeps running forever for some reason if it's interrupted. So when you run this function, it seems like it runs forever if it's interrupted. So now that this is all set up, I'm going to rerun this. I guess I'll just rerun them all, but I don't need to rerun them all. Okay, now, whoops. Now I'll go back to this guy and rerun it. So the coordinates should be 0, 0. Yes, I want to continue. 3, 4. Still no print statement. Oh, maybe I have to answer no. Okay, so yes, I did have to answer no for it to actually execute that distance function. So what's the problem? What does this mean? Unsupported operand types on string and string. So it's this line right here that's failing. Xdiff equals x2 minus x1. What's the value of x2? Well, it's telling me it's a string. So what's 2 minus 3 or 0 minus 0? Well, if they're strings.
Oh.
Like what's George minus Chloe, my dog's name? What are those strings? Like,
Nothing. You can't come up with a.
yes,
a
that's what this is saying. Unsupported operator types, you can't use minus on strings.
Right.
So what's the solution there?
You got an INT to values.
Yes, we have to int all the values. We could actually do that right here. int. Whoops. int. So it's instantly converting them into integers. Right there. I'm actually gonna while I'm at it, because I don't like this, I'm actually gonna put this statement down at the very, very bottom, because that way I won't have to enter no before I get the answer and I'll see it. I just prefer it that way.
So did you delete the other one out of it?
I just took that add another point and put it at the very bottom of the. So I'm going to run that. Can't assign to a function call. Okay, so it won't let me do it that way. Sorry.
So once you say input, it's importing text strings. We really should go on a mathematical strings, correct?
Right.
We have to do it after.
Yes.
So you got an INT that function after that.
Yeah, it won't convert it to.
It can't be simple, right?
Yeah. x1 and it has to be like this actually. x2 equals. So you've got.
That's supposed to be y right there. Y, my y.
Yeah, you're right. Y. Okay. And it should be 1.
Yeah, y, y.
Sorry. Good you're catching all this though. Y 1 1. Okay.
Y1 equals.
And then the same thing up here. It's not a lot. We can't actually do this.
You got an INT those.
Yes.
So you're telling them what you want to do. You got to convert your string statement all the way to a.
When it's user input, that's correct. It's always going to be a string. Let's see what this is saying. Yep. Still saying I'm talking too loud. All right. I think we should be. Cross our fingers. Yep. Okay. So 0, 0, 3. Whoops. I did it again. Let's run that guy again. 0, 0, yes. 3, 4, enter. Yep. Okay. So now it's working. So I'll just leave that up there for a second. So what it's doing is it's getting a number, then it's asking if you want another point, and if you do want another point, which we almost should always want another point. You do agree? Like, why should we let the user only have one, ever enter only 1 point? They should always have to enter at least 2 points. So maybe we should just get rid of this line right here, right?
And another point. Just let it do it automatically.
So it would automatically do 2 points. So in order to do that, I'm just going to go like this. Do you see how that's always going to make it so that it goes into here? So now it's going to run this. It's just going to go directly into here. It's not going to ask the first time. That's why I kept getting tripped up. And then it's going to enter the points, and then it's going to calculate that distance and ask if you want to return another point. So now I can still say yes, I want another point. Okay. And remember, it's like my pen now is at 3, 4. And so if I want another point, let's just test going back to 0, 0. Again, the hypotenuse is 5 because I went up and back. But now let's test, what's another perfect right triangle?
9, 13.
Is it 9?
No, I don't remember.
Yeah, anyway. Well, the doubles should work, right? So 6, 8, 10 should work too, right? I would think. Let's see. 6. Oh. So I got out of it, but anyway.
Mine's still freezing. I'm doing that activation.
Run. Let's try running it again. So 0, 0. So now it's going to go right into it. 3, 4, 5. Add another point. Yes. I'm just going to enter a random point. 5, 6. So now the distance between 3, 4 and 5, 6 is 2.82. It sounds reasonable to me because we're just going up 1 and over 1. So did you try the getting out of it?
Yeah.
Getting out of Jupiter altogether?
So that shouldn't show up there, right? Why?
Try enter something.
So,
The next one, yeah.
I didn't
Oh,
start
so
with
you just
zero.
changed this to input Y. Just change it to just Y.
Oh, okay.
See what I'm saying?
Okay, but it'll still run though, right?
Yeah. Well, if we didn't have this statement right here, it would say user input doesn't equal anything. It wouldn't run this statement. So we're setting up. Lots of times when you write a loop, you need to initialize variables. In other words, you need to create variables that are going to be used inside of the loop. When we did the total earlier, that was an example of initializing a variable. This user input is actually a case of initializing a variable because if that variable didn't exist, the loop wouldn't even start.
It seems like when you press run, when something's already open, like when it's already trying to run, it just freaks out.
It could be, but yeah, you should be able to hit stop and then run, but that doesn't always work. So sometimes I needed to restart Jupyter. All right, so this is 90% done, 95% done. Right now, we just keep getting the distance between the last point and the current point.
So don't tell it if it makes a complete triangle. Is it telling it that it makes the triangle? Or just
We're not really doing triangles this time. We're just doing the distance between points.
Oh, this too.
Now we're using the concept of the Pythagorean theorem, which is triangles. So maybe that's what you're thinking. But so we're doing we're getting this. In fact, let's just file save. Go back to our Cartesian coordinate system. We did 0, 0 first, and then I did 3, 4. So that's right here. And then I calculated this. And then I did 5, 6. So I did 5, 6. And I calculated that distance. Now that distance is 2.82. So what I want to do now is, instead of getting each of these individual values, I want to get the total value, that distance. Well, that distance is just this distance plus this distance, right? So I need to modify this in order to give me the total distance rather than just printing the current distance. So I could do that actually the exact same way I did that other function.
Number 1, number 2.
Is this the same thing opened in 2 different notebooks? I wonder if that's one thing that's causing a problem. This and this. Yeah.
So that number that it came up with, that's the value. So can you add those two different values up?
I could. Yeah, here's the looping. Okay. So did you see how we did this? See, total is equal to 0, and then we're adding the total up each time. That's what we have to do here, right? So I'm going to go ahead and start that. So total distance, I'll just call this, I'll just call it total equals 0. So what could we do here? Well, how can we change this so the total distance is going to always equal the total distance?
So
remember before we had a total equals total plus some number, x, right? Okay, so how can we modify that so that each time through the loop, that's going to add on the distance to the time, so we get the total distance that it's gone so far.
So the first two total gave you a distance, so they get x1 plus y1, and then the second value is the second set of numbers. Is that correct? x2 and y2. So those two values together, wouldn't that equal the total?
You need to add the distances together.
Right, we need to add the distances together. So how do we do that? So we've got 5 and 2.82. So where in here is responsible for showing me the value 5?
Okay.
Print
Get
distance.
a y coordinates of okay. Distance.
This returned 5, right? So if I take this value here and replace it with x, do you see how it's going to, the first time through the loop, what's total going to be?
5.
Because it's going to be 0 plus 5 is going to return 5. The second time through the loop, what's the value going to be if I put this up here?
It's going to be the smaller value at the bottom, wouldn't it?
Yeah, it'll be the second time through. So x will be that. This will be what?
First point.
It'll still be what it was last time. What was it last time?
5.
5. So 5 plus this. So what'll that be? 5, 6, 7. It'll be the total, and it'll keep going. You see that? So when we put something here, we're going to get the running total each time.
Okay. If they already ran this course, I can take that value that is already run because they already run the values, right? I just can add the 5 plus the 2 down there because the function already was run.
The function can get run as many times as you want.
Yeah, but since you already got the value of that 5, is there one complete statement that? I mean, the first time through, does it store it in a box and say this is the number 5?
Mm-hmm.
And then the second time it runs again, is it stored in a block? It said this is 2 point.
Mm-hmm.
Can I add those two values up just by them being stored? Is that what you just did?
Yeah. So that's what I did logically, but you're saying, I think one of the questions you ask is, if I ran it before, and then I destroyed it because I ran it again, how do I get the last number, right? Yeah, so that's what's happening here. I'm taking the current distance, I'm storing the distance in there, and then I'm adding it to the total. Okay? And so now the total is always going to be running total. So the next time through, I'm just adding the current distance back to the total. So it's going to be cumulative. I'm running through each time, and I'm taking the current distance and adding it back to the total. So that logically, all I'm doing is saying, oh, the distance between those 2 points was this. I'll add that to the total. The distance between those 2 points is this. I'll add that to the total.
It's like a checkbook.
Yeah, you just keep writing things down and adding it to the last time. So now it's going to work. In fact, what I'm going to do here is say print total, comma, current distance. So now when I run this, I'm going to think about this slowlier. Okay, I'm having that problem again. Okay, so just to be clear, this is how I'm getting out of that problem. I'm shutting Jupyter down. I saved it first, by the way. And then I'm going to turn Jupyter back on. And then refresh this page where it says connection failed. Okay. Make it bigger again. And I'm going to run this other one just in case. I don't really need to run these other two. Run that one. Okay, so now I'm back in business. So 0, 0. Yes, I want to. Then 3, and then 4. So you can see the first time through the loop, distance and current distance are the same. Yes, I want another one. Let's go. Let's go back down to x will be 8. Oh, sorry. Yeah, 8's fine. Now let's go 0. We're gonna go back that way and then 8. So now the total distance is 10 and this is 5. What I did is I went like this. The first one was 0, 0. The second one was, so it was right there. Actually, I'll make this a different color. Right there. The second point was 3, 4, so it's about there. And the third one was 0 for x, so that's right here, and 8 for y, so that's like way up here. Okay, so that's why it did this and this distance, and together it was 10.
Could you do this here?
What's that?
This here. So when you first said give x coordinate your y coordinates, could you tell it to let x equal let x coordinates equal that input? Once it said, well, I'm not saying let x, but I'm saying x equal where that value 5 printed out. So once you got that value, could you at the end say print x, print y? I mean the x value plus that y value, wouldn't that be? Could you just print that one statement rather than doing all those statements again? It will print out 5 plus whatever the number is.
I mean, I could print out the x and the y coordinates each time, but the goal here is to just get the distance.
Yeah, but what I'm talking about is you once it prints out the 5 values, you have to run it to get the store value. But if you let x be, x be, well, that value printed out with, you would call that x, right? Or the first distance.
So you're saying you want the distance to go into the next function?
The distance value would already be stored there. You would say x, y, whatever the x, y is, to be stored as that 5. And then you do the other one, it'll store that value and just print x, y rather than have to do all that extra stuff.
I'm not really sure what you're trying to get at.
It's just something I need to experiment with.
Yeah, you could definitely experiment with it. So I'm gonna say yes. I want to add another point and just do like 100, 100. So it's like way out there. So now the current distance that added on was 135, and 10 plus 135 is 145. So we're getting. So this is the total distance that we're moving. Like if you can think about our little turtle that started at 0, 0, went to 3, 4, went to 0, 8, and then it went to 100, 100. The total distance the turtle traveled has been 145. Okay. So I'm going to say no, and that'll exit out. So now I'm done. This is actually like, I'm going to cut this cell out because it's not necessary. But that's I think I actually did the entire program there by accident.
Well, it was a learning experience looking at
Oh
this.
shucks.
I see a lot of different ways that you can probably
Yeah,
shorten the code, but for learning experience, I can see why I would do it.
Yeah, there's definitely different ways you could do that. But let's see. Okay, using the function, calculates the length of a polygon, use a while loop. Yeah. So I, I think that your question prompted me to actually finish it off, actually. So, yeah, anyway, that's great. That's fine. So this is completely done according to the way it was written. But I had meant to like leave this addition part and point and refer you back to.
Can you still leave that on there because I want to test a few of the different ways that.
Well, and this will be uploaded to the
Okay.
course website, and you could change it if you wanted to, for sure. I mean, that's one of the great things about interactive Python is you can change it.
So if I pull up one of yours and start changing it, will it override yours?
No.
Okay, good.
Nope, you're just doing it on your computer. It's just a text file. You're modifying yours, and in fact, you could download mine, open it up on your computer, modify whatever you want, and if you get to the point where you're like, I totally broke this, I just want to go back to the beginning, just download a new copy from the
And
internet.
just chunk the out.
Yeah.
Well, I want to experiment so I can see if I can get the same values that
I
you
don't know, I
get,
break it.
so that you give me an understanding of.
Yes, you can do that. If you want to try to do this differently, you can. Okay. All right. So what I'm going to do is the last one that you're going to do is actually what I'll do is I'll leave that almost totally up to you guys to do, and it's not actually that hard. So let's look at the assignment here. So the last part, we're gonna calculate the distance on a spheroid rather than using Cartesian coordinates. I have already written a function that calculates the difference between 2 points on a sphere. It calculates the distance around the top. So let's picture your. I don't have a. This is a geography room. There's no globe in here. But what we're doing here is, given 2 coordinates, we're calculating the distance between those 2 coordinates along the globe, assuming we're not going over any mountains or anything like that. So at sea level, the distance between 2 points, anywhere on the globe, okay? It's called the Haversine function, okay? I've already given you this Haversine function. So what you're going to do is you're going to modify the program from number 2 to calculate the lengths along a sphere. So instead of giving it x and y, you're going to give it latitude and longitude. I don't even care if you call that x and y, okay? Which one should be x and which one should be y if it's latitude and longitude? Yeah, latitude is usually accepted as y, and longitude is accepted as x. And that's the way, like if you load a file into ESRI, that's the way they'll interpret it. Because that way it plots, like, if you have a coordinates that are all x and y, they plot the same way they would kind of plot on the globe, except for they're stretched out towards the poles. Okay? Okay, so what are you talking about? Well, if you go back to M2 here, there's already a file called haversine.py. And if you open up haversine.py, there's already a function here. Too small. There's already a function here called points to distance. And look, it accepts S long, S lat, E long, E lat, and those are actually in the same. Those are actually in. So what do we decide longitude was?
North and south, up and down.
Latitude, longitude.
Yeah, longitude up and down.
Longitude lines go up and down,
But they measure left or
but they actually measure east and west. So they're x. So this is X, this is Y, this is X, and this is Y, right? So what did I just say that function has the same signature as the function you're already using. And so you can actually copy this in wholesale. Just copy this function in.
The whole thing, like from the depth all the way down.
Yeah. Well, here is actually just an example of how it's used. So here, I'll show you this. Let's copy the whole thing over to a new Jupyter notebook. File.
Going all the way to the import map.
Yeah, I did the whole thing, cover to cover. Oh no, I made a mistake. But only one little minor mistake, and that is that I forgot to put this in parentheses. So you do have to change that. I'll fix that up on the website. Other than that, it should work.
You said points.
Yeah. The very end part that says that had a print statement. In other words, the example of how it's used was the only issue. So now I'm just going to run this just to show you that it does work. And it's the distance is in meters. So these are latitude and longitude, longitude, latitude, latitude, and this is distance in meters on the globe. Okay. So that works. Again, the only difference here is that, in fact, I can do that right. I can do that right now. Did I just knock something over? It sounds like. Okay, so if I go into here and I just put parentheses around this. Fixed for.
You want to, this is 2.3, right?
Yep. So now this is fixed, by the way. Yeah, this is 2.3.
Did it fix it automatically or you changed it?
I fixed it's now up on the cloud. It's on the GitHub site. I changed it. Okay. All right. So you might say, well, you've got two functions there. Well, that's because this function calls this function. See how recalculate coordinate is called right here, because it basically converts the math, the degrees that you're given, because the function is actually written so that it accepts radians instead of degrees. So it recalculates, it does some of the math that's necessary. But that's actually not the point of this. The point is not that you know how to write a function to calculate the 2 points on the globe. In fact, if you look at this, I said that I wrote this function. I was actually totally lying, I guess. This function is available on the internet. Okay, and that's one of the things that you'll do, especially as a scripter in GIS, is you'll use OPC a lot. Okay, that's a acronym for other people's code. So OPC. So I used OPC, and I have other people's code written, and you're going to implement that so that you can write your function. So this is just an example of how it could be used. What I actually want you to do is adapt this code, and you put the code from what we've already written in here, so that instead of asking for these coordinates, you're just gonna give it these coordinates. You're gonna have to change a few things. Okay, let's think about some of the things that you're gonna have to change. They're gonna be really minor, but you're gonna have to change a few things. Let's think. Anybody think of some things? We can do this as a group. What's that?
So are you talking about putting in the actual point for it's the 89.34, and then you got another number behind it. What is that second set of numbers? That 32.3, what is that?
That's the latitude value.
of those two pieces right
This
there.
is the longitude, latitude of one
yeah,
coordinate.
Okay, I see it. I thought I
Yep.
messed up on it. So, what's the question again, Doctor?
In order to call, okay, look at this.
What is the function?
Look at this function right here.
Function?
This code right here. In order to call this code, what do I have to change in this function? I mean, in this in this code, in order to call that function. The most obvious thing, there's one thing that's like the very first thing you'd have to change, and that is that it's a different function, right? Since it's a different function, what do I have to change in this code to call the different function?
Well, it's you got to call the function that you actually want to use. So that call function got to be already defined. So
Right. Yeah, obviously, I need to copy that in there. Well, let's say, okay, let's ask this a better way. If I were to copy this, just this part right here, Control C. If I were to copy this in here, it wouldn't run, right? Like, now I'm going to try to run this guy, and it's going to start to run 5, 3, 6, 7, and I get an error. Distance is not defined. Why did I get an error there? That's the first thing that you're going to need to change. Yeah.
You're gonna have to change.
What am I doing right here? What is this line of code doing?
Well, you don't have any value for that.
Straight line distance.
Yeah.
It's straight line distance, but what is it doing? It's calling a function. And that function doesn't exist on this workbook, does it?
No.
So it doesn't know where it is. So the name of the function is different. That's what I'm looking for.
Right.
So you need to change the name of this function to the name of the other function, right? In order to actually have it work at all. Okay? All right, anything else that you guys can see that needs to be changed?
Are you saying distance has to be changed to the name of the new function?
Right. What is the name of the new function?
The name of the new function is what at the top of that?
It's points to distance,
Okay,
exactly.
points to distance.
So
Yep.
we should copy what we did from question 2 onto the question 3, and then just change that call, and then it should run.
That's an acceptable way to do it.
Current
It
distance.
should run, but there's some finesse things that we need to do. Some of them would be absolutely required, and some of them are actually total finesse things. Okay? Like, for example, I'll give you an example of a finesse thing. So instead of asking for x and y, you could ask for latitude and longitude, right? Okay?
To make it a
Right.
fish.
Right. Now, what's something else that you could do that would be a little bit more required?
But you need to change anything over to like a floating point.
Yeah, exactly. These are integers. If we're always converting to integer,
Take away.
we're going to chop off the decimal place, and that's not going to work for some coordinates.
So we changed it to
We're rounding off pretty good. Like in some cases, that's over 1,000 meters of space, right? That's too much. You know, the distance between 1 degree of latitude at the equator, yeah, is a big distance, close to 1,000 meters.
So INT will be float.
That's right. Yep. So go ahead and modify all of those.
To float.
What's
The INT would be changed to float.
Yeah, FLOT, exactly.
FLOT?
Yeah.
Okay.
Yep.
so no A?
But back to one thing.
FLOAT, yeah.
So you
You're right.
change current
That's
distance
what you typed in.
to point to distance. You change current distance to point to distance.
No.
You change the distance to point to distance.
Mm-hmm.
Okay. I always wondered.
It's just the name of the function. So this is the function call, and you have to call it. Now, I did go in and actually change the point to distance so they had the exact same signature. So you don't actually have to change any of these variables unless you want to. You could change the variable names, but I don't see any reason to change the variable names because the variable names are just variable names. The end user doesn't know what those are, so you can leave those the same.
We don't really need the ending point part of it, where the total's adding to the current distance, all that part. Because that's not a part of the question, right? We only want the length of the one line.
You want the mean, you're doing the same thing where you're moving around.
Oh, we are doing
Yeah.
it? Oh, okay, okay. I didn't know.
Yeah, I think is that the. I mean, I just asked you to re.
It just says to calculate the length of of line along sphere.
All right. I know we're getting kind of.
It's not multiple lines, it's just single line.
Well, that's not what I had in mind, but let me see what I wrote. Is this M2?
So we just drop off the Y2, Y2.
M2. Calculating the distance on a sphere. Use the average line formula and modify the program from 2 to calculate the length of a line. I should say a polyline because that's what I meant. So basically, what I meant is that you're going to do the same thing for moving from point to point on the sphere. Okay.
But it's gonna be on the globe.
Yep.
Is
gonna
there
be
any
on globe.
points you want us to put in the show, or just put whatever we want?
Here's just whatever you want.
Okay.
Yeah.
So
Next week what we're gonna do is build on this, and we're gonna actually use what we call web service to go out onto the internet and ask, where's Los Angeles, California? And then it's gonna return an XY coordinate, and we're gonna use that XY coordinate to calculate the distance between two different cities using the web service. So that's where we're going. But anyway, sorry, what was your question? Somebody said a question before?
I was thinking out loud.
Okay.
Just saying, so once we change everything from integer to float, and then change just from the distance to the points to this distance, it should be good to run. I mean,
Right.
besides finesse things.
All you need to do to get it to run is change the function call to the right function call.
And then the integer to float, then not chop off.
Right. And then to get it to be correct, all you need to do is the float part. And then the finesse would be, the distance. And then you could say, because now the units are different, the units are in. So another finesse thing might be to to report the units to the user, things like that. Like, just because, who knows what units these are in now on here unless you tell them.
Couldn't you want to put in something more lined up with map coordinates too? You don't want to have all these points, like this distant location with all these floating point numbers. Wouldn't it be a shorter version of it? Could you make it where it makes sense?
Yeah, you could.
I'm gonna try to run it with your numbers and see if it goes through.
So the like this would be, like I said, it doesn't actually do the over the mountain, like follow the mountain up. So this would be more like how many frequent flyer miles would you get from flying from these cities? And I think they actually do use a very similar formula for figuring that out.
When you ran your original, the one with just the point distance, it was like 882, right? That was okay, cool.
Yeah.
Sweet.
Yep. That's putting it. She's just saying that she's testing it in her new one using these same numbers as X1 and X2, and it should produce the same number. I don't know what these are for sure. I don't know where those locations are. That could be pretty close to us though. This one.
What do you think that's Hattiesburg?
Yeah, it could
I know
be.
New Orleans is almost negative 90 on the latitude, or not latitude. Yeah.
But yeah. But you could kind of test it by typing in coordinates of New York City. Yeah. And then you could calculate coordinates of, so you could type those in, and they should be pretty far apart. So yeah, it does look like, because this is the northing, it does look like that number is pretty far. It's pretty close to us because we're closer to 89, and we're about the same latitude, a little bit lower actually, than Los Angeles. We're south of LA. Okay, so if Are there any other questions? I know that, I mean, this is about the time that we should finish. A little bit late maybe, but.
So when we save our code and then we just open it just to make sure that it runs in the Python format that we saved it. So for example, like I saved the first one I did, and in Jupyter, it goes all through the processes and gives me the answer. This is a triangle or this is a triangle. But whenever I open it from my save file, it lets me do all the inputs, and then it closes whenever I hit enter on the last input.
No, let me take a look at what you mean, because I'm not understanding that, but yeah, once your Python notebook works, then you can turn it in.
So for example, if this is a triangle,
Right.
here. Oops.
Well, that is is this the same file as this?
Yes, sir.
Okay. Yeah, so you're running it from, here it's being run from the command prompt, so as soon as it's done, it closes the command prompt. So it's actually working, it's just not showing, if you want to actually see it.
Well, just for like grading purposes, so whenever you pull it up.
I'm gonna open it up in the notebooks.
Okay.
Yeah. But you could just enter one more. Just say something like done, question mark, or just done, just type in. So if that's the same, if you're saying this is the same file?
Correct.
So I'm gonna run it. How do you run it before? You
Just
double
double
click. Yeah, so now you're by Python. Are you sure that's the same file?
Oh, I'm about to save it again, so I downloaded it and saved it.
Okay, so you downloaded it by saying file, download as, yeah, so yeah, Python.
Then you can open it from here. And I can save.
Yeah, now do it. Now it'll wait,
Okay.
see, until you actually press enter. So that's just a
So
minute.
do you want us to like
Sure.
maybe just do like our initials at the end of it or something?
Actually,
I mean, you can do that, but I know why it's doing that, so
Okay.
you don't have to do anything if you don't want to. In fact, if you just put nothing in the prompt, it'll just stay there until you press enter.
Okay.
I mean, it'll work. Yeah, so. So that's a good question. So if you want, you can turn in this file, which is actually right here. It's called IPYNB. You can upload that, or it is kind of more packaged because it's no longer a notebook, and that's what you were saying there. Is if you say download as and you just save it as a regular Python file, then it'll run from a command prompt. So that's an option. Either one's acceptable to turn in though. You can turn in your notebook, or you can turn in the actual Python file. Just to make sure all the cells run if you're going to turn in a notebook. All right. I'm going to save this as Python, sorry, Raver George 2, 3, 2019, and hit rename. And then I'm actually just going to close all my Pythons.
And you're gonna save it on GitHub site?
Yep. So all of these are new things that I've made. I'm going to close down Jupyter so that all these checkpoint files will go away.
And it's gonna be on the M1 site?
It's going to be under M2.
Oh, it's on M2.
I'm gonna open up GitHub again. They'll be there here in just a second. So now, if I say after class 2019. Master, push to origin. Oh, okay. Okay. Well, I made a change online, so I had to pull and then push.
What's pushing?
Pushing means to like put my local changes up,
Oh,
but then it said you can't do that until you
close all your things.
until you pull the changes that somebody, it basically said somebody else made some changes. It was me. I made changes directly online. So now these are all there.
Okay.
So you could see actually the 2018 version after class, and then the 2019 version is right there. I should actually put all the 2018 versions in the archive, which I did. Here's the 2017 versions, but maybe I'll organize that better later. But all the things we worked on are there. So here's the logical operator, the looping, the mod operator, functions. They're all there. Okay. So